Good afternoon, everybody, and welcome to Hydrogen Fuel Cells Europe here at the Hannover Messe 2023. I see some people found the front seats already. People in the back, these seats are really nice. They're very comfortable. Also the people standing, we have plenty of places, and we have good reason to sit down because we have a very interesting topic that we will be discussing. I will be talking about Power to X and how this is on its way to a true scale-up. I will be talking with the head of department Sustainable Synthesis Products at Fraunhofer ISE. Can I get a warm applause for Achim Schaadt?
Okay. Thank you very much.
Yes, welcome. Find a seat.
Thank you.
All right. Welcome to the public forum over here.
Thank you.
Yeah, so Fraunhofer, every year, again, I am surprised by the amount of booths that Fraunhofer has at the Hannover Messe, because it's all over the place, and by now I have learned to look at those last three letters, right?
That's right, yeah.
That's the important thing. So here with Fraunhofer ISE.
Yes.
Okay, so what does it stand for? What is it?
Yeah, we have our booth right over there, just behind the stage. So it's about solar energy systems, and the system part is really important. So it's of course about solar energies, but we see the whole perspective of the energy system. That's our goal from the founder, and this was further developed from our side. So the hydrogen technologies come into the game. So for many years we work also on hydrogen technologies. And Fraunhofer, okay, it's about our mission, it's about applied research. That's our mission, that's important for us.
Okay, so research and then specifically into solar energy systems. And as you said, that word systems there is very important, right? Because we're talking about the full system here, of which hydrogen is a part.
Yes.
Okay, so hydrogen, the solar energy systems, what is it you guys do then? What can customers expect from you?
Okay, our goal is to reduce emissions, to reduce CO2 emissions, but also local emissions. That's our target, and we tackle that with thermochemical processes and materials that we develop. Technology development, material development, and we do techno-economic assessment in order to reduce costs and to bring new technologies into the market. That's our goal.
Okay, so that's consulting. You help your customers develop new products, but also the synthesis processes for these new products.
Exactly. So we compare different processes, we screen catalysts, and do really consultancy for the different customers along the Power to X value chain. From the wind turbine producer to the shipping company, to the automotive industry, the chemical industry, everything is connected if we have the sector linking, and all of these customers are supported from our side in order to do their business even better. That's our mission.
Okay, so we just called it products. You develop products, the process is to synthesize those products, and earlier on we talked about Power to X. Very mysterious, the X in the product. So what are we talking about? What are these products?
So we focused on methanol, methanol to X, and ammonia. These are the main molecules we look at. As we see that we have quite efficient synthesis pathways already, but now we have, of course, different challenges. So we have, of course, CO2 instead of fossil syngas that you use to produce the methanol or the ammonia. We have more fluctuating conditions as we use renewable energies compared to the stationary fossil processes. And this faces challenges to the catalyst and to the process, to the material. And the goal is, of course, to have still a stable and reliable process. That's our goal, but sustainable.
Yeah, okay, that makes sense. And what are some of the customers then that you are working with? Are these where in the value chain are these located?
We start really from the very beginning. So it's about investors, it's about wind turbine producers, shipping companies, aviation industry, so TUI airports, for example. These are our customers. So Maersk, for example, are also interested in our work.
Really, all of them actually, the full value chain.
The full value chain, exactly.
Okay,
yes.
Interesting. Also for the viewers, by the way, if you have a question, you can just raise your hand and I'll come find you. Okay, so the full value chain, let's give some more examples for that. So we were talking about one of your projects earlier that I think is very early in the value chain, Picasso.
Yes.
Introduce the people to Picasso. What is this project about?
Of course, most of you have heard about the Haber-Bosch process. So it was invented by Haber and Bosch about 100 years ago and was really a revolution in terms of really producing synthetically ammonia from nitrogen and hydrogen. So this is quite fine, but now, as I said, we have different conditions. So we have to use renewable energies, and we want to go with our Picasso project to milder conditions in order to produce renewable green ammonia. And we do that by, of course, material innovation. So we use more active catalyst that it operates at lower temperature and pressure. And we want to apply absorption enhanced reactor in order to avoid the loop that's typically necessary in the Haber-Bosch process. And this, what we have shown is that we can reduce the energy that's needed to carry out the process. And this would reduce, of course, the cost in the end. That's our goal. And our estimations shown that we can save up to 95% CO2 emissions. This is something we developed with our partner, that's ISE from Japan. They bring in the catalyst in this case, and we do the process engineering and the testing. That's the starting point, and we go further in the value chain. So we want also to investigate the ammonia reforming as well, because some customers also want to have the hydrogen back in their application. So it depends. Some customers just want to use it for fertilizer. Some of them want just to use the hydrogen, and they need the ammonia reforming process. And there we are also active in developing efficient processes where we heat the catalyst directly by electricity. So it's more efficient as we can really bring in the heat directly where it's needed, and we can reduce the size of a reactor. So lots of innovations are possible on this whole value chain, and we want to have this impact and to bring it into the market in the end.
Yeah, so you're really collaborating with a lot of different parties then in that whole chain. Another project that comes to mind then is with the sustainable air, the airplane fuels, the Safari, I believe it's called.
Yes.
It's a good wordplay, I have to say. SAF and then
Thank
the
you.
RE, Safari. It's nice. That's with methanol, I believe, right?
It's based on methanol, exactly. The idea is really to have renewable aviation fuel, sustainable aviation fuel, SAF, based on advanced reaction and process engineering. So process intensification is really the core of our development. In Picasso, it's about the integration of absorption in the separation into the reaction to reduce the equipment, so the capex in this case. And the same we do also, and that's the idea in Safari, to have really process intensification to save equipment and to have in the end a higher efficiency of jet fuel from the hydrogen that's used. Of course, hydrogen is the most expensive educt that's applied, so it's really valuable and precious, and we have to be careful, and we have to have an efficient process. And that's our goal in Safari. So based on methanol, our simulations shown that it's a more efficient process, and that's something we would like to show. And we will design and build and operate a pilot plant producing sustainable aviation fuel in order to get the final approving in the end for ASTM. That's needed, that's the certification process that's needed in order to really use this fuel later on. That's something we work on. So it's a 6 years project, so we have some time to develop the process, to build the plant, to operate the process, and to really bring this ASTM process forward.
Yeah, so you're really still at the start of this project, right? This is really something that's happening now. And
Exactly,
yeah.
exactly. It started, so we got the grant in December last year. So we had the kickoff, and there was a big conference in March in Berlin. So, but now we are really busy going on and planning the pilot plant and proceeding with our tests and simulations.
Yeah, interesting. Very important use of hydrogen as well, of course, all these fuels. I'd like to open up to the audience again, if there are any questions. And if there are none, then I do have a question. You are super deep into Power to X. The way I hear this, you are very experienced, you work with different projects, different partners, the full value chain. What are some of the trends in Power to X specifically that you are noticing or that you can discern from your expert position?
Yes. What we've learned, of course, that we cannot easily just use the fossil-based process, as we have now different conditions. So we have fluctuating renewable energies, the wind and the solar, and we have to handle and to deal with that. And now we have to provide with renewable energies. We have to provide the water for the electrolysis. We have to deal with that, with this fluctuating conditions. So we think that process intensification is really important to keep the process low cost in terms of less equipment, robust equipment that can also be operated, for example, on offshore platforms. And this is something new that has to be tested and investigated. And we provide the technology basis in order to have a robust platform for testing and applying with the synthesis pathways in the end. If it is Picasso for ammonia and Safari for methanol to jet fuel, for example. So process intensification is a key what we see.
Interesting. And that is Power to X specifically. I know we've been talking before, of course, and I know you have been active in Fraunhofer ISE since 2000, what was it,
2005?
2005, so that's almost 20 years ago.
Yes.
What did your work look like back then? How did it change? Because you've been working with hydrogen from the very beginning, right?
Yes, that's true. So
how did it change?
Yeah, I had the pleasure to participate a lot of times in Hannover Fair, so it's good to be here again. So what we did in the beginning when I started at Fraunhofer ISE, it was about reformer systems. So we did reforming of fossil fuels. So it really changed now from the using of fossil-based reformer processes to really sustainable processes. If it is synthesis, but also we come back to the reforming again. So as I talked about ammonia reforming, for example, this is still important with reformer processes, but now based on electricity more and more. So it's really about electrification of processes. Of course, we talk a lot about electrification of powertrains, BEV and fuel cell vehicles and e-fuels, but also it's now really a shift to electrification of the chemical industry going on. That's also important. And this is something where we can also contribute, as we can really direct the heat, the catalysts, and really bring the heat where it is needed, and so we can really build the reactor smaller. So process intensification is a big key message with different facets of it in the end.
Yeah, so electrification of the chemical sector, that is interesting. So you're saying at first you took fossil fuels as a basis and you took the hydrogen out of that?
Yes.
And now basically we're doing the other way around. So
exactly.
we're making hydrogen so we can create replacements, non-fossil replacements of these fuels. And so basically the reverse.
Exactly, more or less. It sounds simple, but of course it's not in detail. But yeah,
as always with hydrogen.
And it's as you said, it's about also synthesis, storage, and transport. So we have to think about how we can import to Germany or export from other countries to Germany and Europe the energy. That's of course a difficult task, and we have to think about how it's going to happen quite fast. So it's really a question of technology, a question of costs, it's a question of CO2 emissions, and everything has to be put together. And this assessment is also done from our side. So we do really consultancy of this different aspects of the Power-to-X process chain.
Very interesting. Okay, thank you. Yeah, I think we've all learned a lot. If we ever need something with Power-to-X, I know where to find it. It's going to be at Fraunhofer ISE. You can find them at booth D35, which is over there, I believe, right?
Yes.
Yeah, just behind the forum here. So give them a visit if you're interested in continuing this conversation. Achim, thank you.
Thank you.
For your